Hello, today we're going to talk about parallel and perpendicular lines, and I am Mrs. Heaton. Let's think about parallel lines for a few minutes. What comes up in your mind? Maybe lines that run side by side and never meet? That's kind of a way to look at it. Also, what do you notice? The steepness of the lines are the same. So if we call this line 1 and this line 2, we could say that the slope for line 1 equals the slope for line 2, because if the steepness was not the same, the lines would bump into each other. So let's actually get written down our more formal definition here. It says the slopes of two non-vertical parallel lines in the same plane are the same. That's what we said a few minutes ago, that the slope of one line equaled the slope of another line. Now let's think, could there be any exception to that? Could we have two parallel lines whose slopes are not the same? What if we had vertical lines? Those slopes are undefined. How can you say undefined equals undefined when we don't know what undefined is? So let's continue our definition and we'll deal with that. In the third section here, it says two distinct vertical lines in the same plane are parallel, and we have to put that in as a stipulation to cover those because their slopes can't be the same. And then number 2, if the slopes of two distinct non-vertical lines in the same plane are the same, then those lines are parallel. Okay, let's look at a problem about this. We notice that line L right here is parallel to y equals negative 2x, our blue line. Write an equation for line L in point-slope form and slope-intercept form. Okay, to write an equation, we want a point and we want a slope. Well, the slope of our line over here, our given line, is minus 2. Because remember, when our equation is solved for y, the coefficient of x gives us our slope. So that was pretty easy. And then we're given a point that the red line goes through, or line L, and that is 4, 2. So now we have what we need to write the equation. So using point-slope form, we'll say y minus the y of the point equals the slope times x minus the x of the point. And then we have the point-slope form of the line. If I want to get it in slope-intercept form, I'll solve for y. So to solve for y, first of all, I'll simplify the right side by using distributive property. So y minus 2 equals negative 2x plus 8. Then I will add 2 to both sides to get just y. So I have y equals negative 2x plus 10. And that is our slope-intercept form of this line. Okay, we have this equation. Next, we're going to write the equation of a perpendicular line. Now, it's not quite so intuitive to give the equation of a perpendicular line because it's a little harder to get the slope. So we really need to look at the definition there before we try. And here, number 1, the product of the slopes of two non-vertical perpendicular lines in the same plane is negative 1. Well, let's see. If I multiply 1/3 by something and end up with negative 1, first of all, I've got to have a negative to go with my positive so that when I multiply, I'll get negative. And then I need the reciprocal of 1/3, which is 3 divided by 1. Then when I multiply, I get negative 1. So if 1/3 is a given slope, -3 would be the slope of a line perpendicular. Notice these are opposite signs and reciprocals of each other. Number 2, if the product of the slopes of two distinct non-vertical lines in the same plane is -1, then the lines are perpendicular. And of course, you probably figure that we're going to have some lines that are perpendicular whose slopes multiplied together does not give us -1. Now we're pretty familiar with this being perpendicular, a vertical and a horizontal, aren't we? But remember, the slope of a vertical line is undefined. So how can undefined times anything give us a -1? And then the slope of a horizontal line is 0. You see the dilemma we're in. So we need to have a little part in our definition for that. So number 3 says a horizontal line and a vertical line in the same plane are perpendicular. Okay, let's look at a problem now involving perpendicular lines. You'll notice here we have the same y equals 2x that we had before. And that given line is perpendicular to our red line here. The slope of our given line is -2, just like it was before. The slope then of a line perpendicular to it is going to be the opposite sign, which is positive, and the reciprocal, which is a half. So the slope of our new line L here is going to be 1/2. And of course we have a point, -3, 1, that we're given to work with. So we want to write the equation. So y minus the y of the point equals the slope times x minus the x of the point. Now don't forget that this minus is in our formula and this negative goes with the 3. So we have a double minus here. So y minus 1 equals 1/2 times x plus 3. And a lot of you will skip this step, so I'll write it optional. You will mentally say x plus 3. Some of you need to say minus a minus in order to get this step correct. And that is our slope, point slope form. And now we'll go to slope intercept by solving for y. So y minus 1 equals, and I'll simplify the right-hand side by using distributive property. 1/2 x plus, if I put that 3 over 1, show a denominator, then I'll multiply numerators and get 3, multiply denominators and get 2. Now to get just y, I'll add 1 to both sides. So y equals 1/2 x plus, well, those are like terms. If I had the same denominator for both of these terms, I could add them. So let's write 1 as 1 over 1 so that we have a denominator for it. And we would like for that denominator to be 2. So if I multiply the denominator by 2, I'll have a 2 denominator. But then if I do the same thing in the numerator, I've just multiplied by 1, so I haven't changed the value, just the looks of my fraction. So now I have 3/2 plus 2/2. Then y equals 1/2 x plus, I put down the common denominator and add only numerators. And there is my slope-intercept form of our line. Let's move on now to an equation of a line passing through the point -2, -7 and parallel to the line whose equation is y equals -5x minus 8. Okay, what's the difference in this one and those that we saw on the graph? Well, we're not looking at it on the graph. It's basically the only difference, isn't it? Our point's given to us. An equation of a line is given to us. So let's work this very similarly to the way we worked before. To write the equation, we want a slope and we want a point. If I look at the given line, I notice that the slope for the given line equals -5. Since it is parallel to the new line, the slope of the new line is also going to be -5 because parallel lines have the same slope. The point that I'm going to use is the point I'm given, -2, -7. So now that I have my point and slope ready, I can say y minus the y of the point equals the slope times x minus the x of the point. Again, some of those double negative things here. So let's simplify that. And we have y plus 7 equals -5 times the quantity x plus 2. And that is our slope-intercept form. But usually we see our lines solve for y, so let's continue on. I'm going to use distributive property to simplify the right-hand side. So y plus 7 equals -5x minus 10. Don't forget that that's a negative there. A lot of times it's easy to forget by the time we're distributing to the second number that we had a negative. All right, and now let's subtract 7 from both sides to get y by itself. And I have y equals -5x minus 17 for the equation of the line. Okay, we're going to write the equation of another line. This time it's going to be perpendicular to the given line. And the equation is not solved for y this time, so it's going to be a little harder to find our slope. So let's get busy on that. First of all, we want to find the slope here. So when we find it, we'll put it here. All right, to find the slope, we're first of all going to find the slope of our given line by solving its equation for y. So here's my equation, x plus 6y minus 12 equals 0. Solving for y, I don't want the x and I don't want the -12 with my y term. So I will subtract the x and add 12. So subtract x and add 12 to this side. Then, checking my arithmetic, the x's do add out, so I have a 6y. My 12's add out. And I want you to check that arithmetic each time because it's very easy to do the wrong thing. I call it thinking backwards. And sometimes I do it too, so I check myself. So opposite of x plus 12 is my right side. If I divide both sides by 6, I'll get the 1y. Since we're dealing with lines again, I'll divide each term by 6. So when I reduce, that becomes 1. So y equals -1/6 x plus 2. Remember, there's an understood 1 there, so I can pull out the -1/6. And then it's easy to see that the slope of the given line equals -1/6. So then the slope of our new line would be, well, let's think, perpendicular. Okay, perpendicular lines opposite, so it'll be positive. And 1/6 becomes 6/1, or 6. So my new slope is 6. The point is given to me, 4, -9. I'm now ready to write the equation of the line. Y minus the y of the point. Can I think this time minus a minus becomes +9? If not, put in the extra step. Slope times x minus the x of the point. And there we are with our point slope form. We want to solve it for y to get it in the slope-intercept form. So we'll use distributive property. And we get y plus 9 on the left. Distributing, we get 6x minus 24 on the right. And then we'll subtract 9 from both sides and get y equals 6x minus 33 when we have it in the slope-intercept form. And it's easy to see that our slope, sure enough, is 6. And our y-intercept is negative 33. So that's interesting to know, but we weren't asked for that. Okay, this is all that we will do right now. Next, we'll look at average rate of change.